All right, so I'm just kind of doing an audio check, testing, testing, 1, 2, 1, 2. So I can hear my audio. Get started. I think this is gonna shut that down. We can shut that down. Here. All right, and then we want to share the screen. Sorry for the background noise. Just have to kind of. And let me hit save on my attendance, and I'll check attendance again at around 2:15 for the stragglers. Let me go ahead and save and set this thing back up. All right, gentlemen, welcome. Let me see. I can't think of any real announcements. I felt like my announcements this morning were a little bit better because I was more clear and was fresh on my mind. But we are rapidly approaching the end. Today, we're going to be working on section 6.3, which is the last review material for exam 3. All right. So exam 3 is going to be over chapter 6, over sections 6.1, 6.2, and 6.3. So this week we're doing 6.3. Next week is exam 3 over chapter 6. The following, there's only one more piece of new information that I really want to go through, which is like a supplemental section. I've already loaded it into Pearson, so just kind of keep working in Pearson like you've been doing, and that'll be there. And then I think we have about 2 weeks to review for the final. So we'll fill that time with review and things of that nature, just getting things in order. Now is a good time to get your Pearson items in order, right? So we're moving into exam 3. You have a solid 2 weeks to get that in order. And my recommendation to order priority, you definitely want to prioritize your exams first. The exams are going to account for about 80% of your overall grade. That's included in the final. It's going to account for 80%. So that's the least amount of work that you can do and earn the most amount of points, right? And then once your exams are in order and you've done your exams to where you feel like you can get them or where you want them to be, next I would prioritize the quizzes. The quizzes, they're fairly short. They should be within reason. I think all the quizzes are about like 5 questions. They should be 5 questions. And then, but I think the quizzes overall are only 10% of your overall grade. And then with that homework, just do the best you can with it. I don't want you to stress out trying to get all the homework submitted if you're not caught up. Because the homework is a whole lot of work and it's only worth it's a whole lot of work for a little bit of points, right? So I don't want you to waste a lot of time and energy trying to get caught up in that homework. The real intent of the homework is really just for you to be practicing to get you ready for the exam, right? But the exams, you definitely want to put your energy into those exams and get those in order. I know I had one student who he was concerned about his midterm grade, and then when we looked into it, I was like, when did you take exam 2? He took exam 2 after I pulled the midterm grades. So I just said that to say, I don't want you all to be stressed about the midterm grades. The midterm grades are just a snapshot of where you were at that moment in time. It has no bearing on your final grade. So as long as you get your assignments on Pearson in order, before the hard deadline of May 1st, and you do well in your final, you're fine, right? The midterm is just a snapshot of where you were when I pulled the grades. It has no bearing on your final grade. Again, let me remind everyone of the hard deadline of May 1st. It's a Sunday night at 11:59 p.m. going into Monday morning. So everything on Pearson is going to lock out, right? You won't be able to make any more changes. And the only thing that you're going to have access to at that moment in time is the our final exam. The idea is that, the intent, the idea or the intent behind the final, I decided to give you like the entire week of finals. So that's Sunday night at 11:59. So I think it's that Friday, maybe at the close of business day, maybe Friday at midnight, something like that. But that whole week, you can work on the final. And then the idea is that once you're done with the final, you're done with the class, right? I don't really want, you finish the final, then you're trying to finish up all these lingering assignments. So you want to get as many of those things in order as soon as possible. So that way when we hit May 1st, you'll be ready. As always, if you have questions, comments, or concerns about anything, just feel free to unmute yourself and get my attention or type in the chat. and we can talk about it. Again, as a reminder, the intent of class time is for it to be like a Q&A or a study session. I just fill it with like the lecture and homework, so it's not so much dead air. But we don't have to do any of that stuff. I have recordings of lectures and other things, so we can lean on that and talk about other things if we need to. There was something else I wanted to mention. Let's see if I can remember. Oh, and then the other thing is just also don't hesitate to email. I know I don't really respond to the emails promptly, but it's always good to have that kind of stuff on file, just to have it written. And then, but if I don't respond to an email within a certain amount of time, just bring it up the next time, the next class session, right? So, it's not that much time that's gonna pass as long as you bring it up during class. I can't think of anything else, right? So again, just if you have questions, comments, or concerns about anything, feel free to unmute yourself. And so this presentation that I'm gonna do, there is a recording already. I basically recorded my session from the students from earlier. I felt like it was a clean, smooth recording, but I'm just gonna do it again for you all live. This is live streaming to my YouTube as usual. I don't mind going through the material again. I enjoyed it, it was fun. And then Friday, we'll go through some of the homework, okay? All right. What time is it? Yeah. I'll check attendance again. I usually check it at the 15-minute mark just to get the stragglers, so I'm not wasting so much time going back and forth with the stragglers. Okay. So with that, today, so this will be the last of the new material from chapter 6 for exam 3. And we're going to be working on section 6.3, geometric sequences and series. A few objectives. One, we'd like to identify a geometric sequence and find its common ratio. 2, we like to find the sum of a finite geometric sequence. 3, we like to solve annuity problems. 4, we like to find the sum of an infinite geometric sequence. Yeah, that's it. Okay. So we have this definition of a geometric sequence. It says the sequence that you see here is a geometric sequence or a geometric progression if there's a number r such that each term except the first term in the sequence is obtained by multiplying the previous term by r. The number r is called the common ratio of the geometric sequence. And basically it's going to be the n plus first term divided by the nth term, as long as n is greater than or equal to 1, right? So with chapter 6, we kind of opened by introducing this notion of sequences and series. I think that was the first one. And then, but section 6.2 was on arithmetic sequences, right? So that's where we were given some initial term, and then to find the subsequent terms, we had some common difference, right? Some common difference, D, that we were adding to the previous term to get the next term. So this is similar. Instead of a common difference, we have a common ratio, where in this case, we're going to be multiplying the same number by each previous term to get to the next term, right? So it's the same idea, just instead of addition, it's multiplication. Okay. So with this first example, we're asked to find the common ratio for each geometric sequence. So for part A, for instance, if we said a sub 2 divided by a sub 1, notice we get 5, right? So find the common ratio. We can say 10 divided by 2, or we could say 50 divided by 10, or we could say 250 divided by 50. In any of these cases, notice we get the same number of 5. So our common ratio for part A is 5, right? And we can confirm this. Notice that, for instance, 2 times 5 is 10, but that times 5 is 50, but that times 5 is 250, so on and so on and so on, right? So then for part B, if we say the n plus first term divided by the nth term, we get our common ratio. So for instance, that would be like negative 54 divided by negative 162. That should be the same as negative 18, or we ask ourselves, is it the same as negative 18 divided by negative 4? I'm just going to jump ahead a little bit. It should be the same as negative 2 divided by negative 6, which is what, 1/3. So it looks like we're multiplying each term by 1/3 in each step. So it looks like the common ratio is the third, right? Okay, all right. Let's see, how do we do? We got 5, and we got 1/3. And again, if anything is not clear, feel free to unmute yourself. Hopefully we're all aboard and we're not all bored, right? You know, it's okay. So the recursive definition of a geometric sequence. A geometric sequence here can be defined recursively. The recursive formula is the n plus first term is going to be r times the previous term, as long as n is greater than or equal to 1. This defines a geometric sequence where the first term is a1 and common ratio 1. Okay. So to get to, given a term, to get to the next term, we say r times that given term. So determine whether each sequence is geometric. If it is, find the first term and the common ratio. So with this, it's a good idea to just list out the first few terms of each sequence. So for part A, for instance, when n is 1, we get 4. When n is 2, we get 16. And then what, 64, 240 plus 16, 256, so on and so on, right? That's the extent of what I can do there. But I think each step, we're multiplying each term by 4 to get to the next term. So we're going to say, yes, it's going to be geometric. The first terms are a1 is 4, and our common ratio is 4. Okay. Let's work on part B. Okay, when n is 1, we get 3 halves. When n is 2, we get 3 fourths. And then what? 3 eighths, 3 sixteenths, so on and so on and so on, right? So it does look like we're multiplying the same. We have a common ratio, right? We're multiplying each term by, what is it, 1/2 to get to the next term. So then our first term is 3 halves, and our common ratio is 1/2. Okay. And then part C. When n is 1, we get -4. When n is 2, we get -24. When n is 3, we get -124, right? I'm going to say that this one is not geometric because we're not multiplying. Like the common ratio from the first to the second is what, 6. But then from the second to the third, it's not 6, right? So this is not geometric because there's no common ratio. All right. So I'm gonna go ahead and check attendance again. And while I do that, I want to fill the air and get some audio. I just watched on Netflix a series called Behind Her Eyes. I enjoyed it. It was fun. It was, I enjoyed the thing. It was let me get these gentlemen. Because I kind of want to talk about it, but I don't want to spoil it for people that haven't seen it, even though it's been out for a long time. So spoiler alert, if a movie or something has been out for like maybe more than 2 weeks, I don't feel so bad about spoiling it because you've had ample time to watch it, but if you do want to watch things, just watch it, get it over with, so that way nobody can spoil it. Here. And then this one. And hit save so I don't lose my work. And let me set the screen back. The stream is still going. I almost stopped the stream. I want to share my screen. Okay. So I don't know if you remember before I was saying, like, so excited about my keyboard, and then I couldn't get it to work, so I wanted a replacement. Turns out the original keyboard actually did work. I just didn't understand how to use it. It's a new keyboard, but I even had contacted the creators of the keyboard, and they were acting, like they didn't get it either. Like they didn't know what I was doing wrong. I didn't think the keyboard had a function key. It turns out it did have a function key. I finally found it. It was in a place I normally, I just didn't see it or whatever. So now I got a second keyboard for free. That was more of the story. I don't know if moral is the right connotation, but that was the conclusion. So I gave it to my friend. Let's see. I think these are good, right? We got
4, 4, 3/2 and a half, and then not geometric. So the first one, right there, you can see it. The first term is 4, the common ratio is 4. Then the first, I probably shouldn't put the F. I wasn't paying attention to that. The first term is 3/2, and the common ratio is a half, right? So we got that one. And then this one is not geometric because not all pairs of consecutive terms have identical quotients, right? There's no common ratio. Okay. Let's see. So now let's look at this notion of the general term of the geometric sequence. So every geometric sequence can be written in this form, right? Basically, you have your first term, then the second term is going to be the first term times r, then the next term is going to be that times r, but then the next one is going to be that times r, so on and so on and so on. The nth term is going to be a1 times r to the power n minus 1, and keep going. Again, while r is the common ratio, since a1 is equal to a1 times 1, which is the same as a1 times r to the power of 0, the nth term of the geometric sequence is going to be a1 times r to the power of n minus 1, right? For n greater than or equal to 1. Okay, let's keep going. So for the geometric sequence given, find each of the following. The first, right? And let's here. So for part A, a1 or the first term is 1. For part B, r, the common ratio, we're multiplying each term by what, 3 to get to the next one? Okay. So then the nth term is going to be a1 times r to the power of n minus 1. So then that's going to be what? 1 times 3 to the power of n minus 1. Okay. Yeah, we're like cruising through this. It's okay. All right, so we got 1, 3, and then 3 to the power of n minus 1. So it's either 1 here, 3 here, and 3 to the n minus 1. Okay. Oh, man. Okay. Let me. Oh, I didn't prep this slide properly. So let's following. Let me duplicate this. Just simple copy and paste. And then this one. I usually suppress the results and try to work it out fresh. I just missed this slide, so we'll do it on the go. Okay. So here it says we're asked to find the 23rd term of a geometric sequence whose first term is 10 and whose common ratio is 1.2. So then we have A1 is 10, R is 1.2. And we also said that the nth term of the geometric sequence is going to be A1 times R to the power of n minus 1. Okay. So the 23rd term. So we're asked to find the 23rd term. So then we're going to say 10 times our R, which is 1.2, to the power of 23 minus 1. Hey, Google, what's 10 times 1.2 to the power of 22? I think she said 562. So the audio was a little bit low. I didn't hear it. We're going to go. Copy. Okay. That's better. So 562.06. Oh no. Oh, I just Put them in the wrong order. I don't know how that happened. So we got 562 106. Oh, 552. Well, again, that's just because I couldn't hear it. But I know it crunched it properly. Okay. And you see the same thing here. Okay. So now the sum of the terms of a finite geometric sequence. So let A1, A2, A3 up to AN be the first n terms of a geometric sequence with the first term A1 and a common ratio R. Then the sum of these terms is given by this. So the same way we derive the sum of the first n terms of an arithmetic sequence, let's do the same thing here, right? Let's start by getting a copy. So the sum of the first n terms of geometric sequence, this is going to be the sum as I goes from 1 to n, and the geometric sequence takes on the form A1 times R to the power of I minus 1. Right? This is going to add up to A1 times 1 minus R to the power of n over 1 minus R, as long as R is not equal to 1. Okay. So let's derive this. You don't have to know this. We're just doing it just for the sake of doing it. I feel like you get a better level of appreciation when you know where these formulas come from. You get a lot good amount of context, right? Okay. So now let's consider a sequence as geometric, and let's add up the terms, right? So we're gonna consider the sum of the first n terms of the geometric sequence. So the first term is A1. Then we're going to say plus. The second term is going to be A1 times R. Then the next is going to be A1 times R squared, A1 times R cubed, until you get to the nth term, which is going to be A1 times R to the power of n minus 1. Right? So that's the sum of the first n terms of the geometric sequence. Now, let's take this and multiply both sides, the left and the right, by R. Right? So we're going to say this times R, and we're going to distribute an R across here. All right, let's do this and see what happens. So now, if we do this, we'll get R times the sum of the first R times SN, and we're going to get R. Let me get rid of this, so because I don't want to confuse it. We're going to get R times A1 plus, and let me do one other thing. So we're going to get A1 times R plus what is it? A1 R squared plus A1 R cubed plus A1 R to the 4. And if you keep going, you add 1, so then that's going to be A1 R to the 8. Right? So now if we say the first sum minus the second sum. So we're going to say the first line minus the second line. We're just going to subtract these two guys. So on the left, we're going to get a negative. On the right, we're going to distribute a negative. We're multiplying both sides by -1. All right? Okay. So now, if we say the first sum minus the second, on the left-hand side, we're going to have Sn minus Rsn. And on the right, you should notice something that happens. Let's do this. We can kind of just we can basically line up the like terms, just like this. Okay? And then, can you see it? If we say the first line plus the second, a number plus its opposite, we cancel. These cancel. This cancels. There's going to be an R4 to cancel this one. I think this guy is going to cancel, and the last term is going to persist. And it takes a little bit of, a little bit of thought process, but the n minus first term cancel and the nth term persists, right? So then what's left over, we're going to have A1 minus A1 R to the N, right? So then on the left, we can factor out the Sn. We're going to have 1 minus R. Factor out the A1, we're going to have 1 minus R to the N. So then now we can, it simplifies all the way down to the sum of the first n terms of the geometric sequence is going to be A1 times 1 minus R to the N over 1 minus R. And this as long as R, I think, is not equal to 1. Okay. But you see we got the same thing as the green at the top. A1 times 1 minus R to the N over 1 minus R. Okay? And again, R not equal to 1. Now let me just check Zoom really quickly. Okay, that's fine. All right, so we were able to derive that and see where that comes from. All right. So then here we're asked to find each sum. We have the sum of the first two terms of the geometric. Let's confirm that this is geometric. Let me see. So when I is 1, I think we get for part A. For part A, when I is 1, we get 5. When I is 2, we get 3.5. When I is 3, hey Google, increase your volume. So it's going to be, hey Siri, what's 5 times 0.7 squared? Hey Google, what's 5?
0.7 squared is
all right, creepy. Let's see. Let's do one more. 1, 2, 3, 4. So, hey Google, what's 5 times 0.7 to the power of 3?
5 times 0.7 to the power of 3 is 1.715.
715, right? And it keeps going. Right? And so I think we're multiplying by 0.70 times. Hey Siri, what's 5 times 0.7?
5 times 0.7 is 3.5.
Hey Siri, what's the answer times 0.7?
3.5 times 0.7 is 2.45.
Hey Siri, what's the answer times 0.7?
2.45 times 0.7 is 1.715.
Okay. So we've shown that we're multiplying each term by 0.7 each time, right? So then we just said, now let's write down the formula. Again, hopefully you have a formula sheet. Every time you come across the formula, you update that formula sheet, you're writing down that formula sheet. Let's see. So the sum of the first n terms of the geometric is going to be A1 times 1 minus R to the power of n all over 1 minus R. Okay. So let's plug in the different components. Yeah, I don't know. My energy just went out all of a sudden. So then for part A, let's see, the sum of the first 15 terms is going to be the first term, which is 5, times 1 minus the common ratio was 0.7. N in this case is 15, all over 1 minus 0.7. Okay. 0.3. Let me just use my calculator to, oh, no. Let me use my calculator to crunch this number. Yeah, I just got sleepy all of a sudden. Let's hop over this one. clear. Okay. So we're going to have 5 parentheses 1 minus 0.7 to the power of 15 divided by 0.3. Okay. For that one, 4.92. Okay. Let's copy. All right. So then for part B, let's see. I think the only thing is, so the power, instead of it being I minus 1, is I. So for instance, when I is 1, 5 times 0.7 is 3.5. Then it's going to be 5 times 0.7 squared. That's going to be 2.45. And then, so basically, it's the same sequence. We have a different start. We start at a different position, right? Okay. So then the sum of the first 15 terms of this one, A1 in this case is going to be 3.5. 1 minus 0.7 to the power of 15 over 1 minus 0.7. Okay. So then we can essentially take the same thing. No, wait a minute. Wait, I need to back up. With the previous one, I think my parentheses looked a little funny. I think I may have either forgot to do it or maybe it was a miss. All right. Let's go insert. It needs to be parentheses and then division. Look at that. Okay. All right, let's do this one. Okay. So that's 16.59. 16.59. Or we can do 58. Let's do 588. 16.588. I just rounded the 3 decimal places instead of 2. And then this other one, okay, it's better. Now we can recall, and instead of that first term being 5, the first term is 3.5. I think everything else can stay the same. Okay, so then 11.611. I just rounded the 3 decimal places. And let's see the time. Okay. So then 16.588, 11.611. Okay, that's fine. It was a little bit different past that third decimal. It's because they took the previous and just multiplied it. Oh, okay. So for instance, if you're looking at part B, again, part A was 0.7 to the power of I minus 1, right here. So then for part B, it's 0.7 to the power of I, right? But this is the same as the I minus 1 times 0.7, right? So basically, it's 0.7 times the previous. So they took their rounded result, multiplied it by 0.7 to get this number, and that's why our trailing numbers are all like that. Okay. All right. So, but I think I feel good about our results. We're fine there. Give me just a moment. Let me check Zoom really quickly. If it allows me to, come on. Yeah, so now my device, yeah, I don't know. I think I'm just getting older. Let me get this student that's just going in. Save. All right, so let's explore what do we mean by the value of an annuity. So let P represent the payment in dollars made at the end of each n compounding periods per year, and let I be the annual interest rate. Then the value A of the annuity after 10 years is given by this. So this comes out of like the compound interest formula, but factoring in the concept of an annuity. Let's just see the next example, and I feel like that'll give us some context on what an annuity is. So finding the value of an annuity. An individual retirement account, IRA, is a common way to save money to provide funds after retirement. Suppose you make payments of $1,200 into an IRA at the end of each year at an annual interest rate of 4.5% per year, compounded annually. What is the value of this annuity after 35 years? Okay. So it's not like the same as compound interest. It's a little bit more because you're still factoring in your accrued interest and a new balance, but then you're also adding an amount once per year at the end of each year, right? So the annuity, let me see. I think it was like P times 1 minus I over N. Which one was in the power of NT? Yeah. Nope, I'm way off. 1 plus. To the power of NT, I think we had a minus 1 and then all divided by I over N. That's how it goes. Let's see. We can account for that. So let's do this. One plus I over N, the power of NT minus 1 over I over N. I think this is 5. So let's plug in the different parts. An individual retirement account, IRA, is a common way to save money to provide funds after retirement. Suppose you make payments of $1,200, right? So that's going to be a P. They're basically adding $1,200 every year, once a year. P is $1,200. At the end of each year, with an annual interest rate of 4.5% per year. So that's our I, but it needs to be expressed as a decimal, so that's going to be 0.045. It says compounded annually, so that means our N is 1. And then what's the value of this annuity after 35 years? Our T is 35. Okay. So then we just plug in those different components. Let me give myself some space. So then the annuity should be 1,200. On the numerator, we have 1 plus I, which is 0.045, over N, which is 1. So we don't need that part. Okay, whatever result we get there, we want to say that to the power of N. And then T is 35, so in this case, it's going to be to the power of 35 minus 1 all over 0.045 over 1. Okay. So then at this point, we just use a calculator to crunch the number. Yeah, I haven't seen it fast. We're almost done. Actually, I think we are almost done, but I think I might defer to my recording earlier to get the last part. mean, it's not, it goes fairly quick. Let me just finish. Okay. Let me just start another one. So then in the calculator, let me see if I focus on the numerator, and then this first part is going to be 1 plus 0.045. We want to close out that set of parentheses. Let me see. This is for the numerator. This is fine. 1 plus, we're going to say to the power of 35. Then we're going to say minus 1. Then we want to close off that numerator and say divided by 0.045. This is okay. No, let me think about it. We got 35 minus 1. Oh, the 1200, right? We forgot to introduce that. So if I call this back, I need another set of parentheses around everything. So I'm going to insert the parentheses here. And one here. And then we want to say all of that we did times. Oh no. So I think we need, oh, 1200, right? Insert 1200. Let me get rid of that star. Let me check my parentheses. Open, open, close, close. So I think I need one more. Let me insert. Let me delete. Insert 2 more, please. Okay. So then after 35 years with that rhythm, we got $97,795.94. Okay. Okay. Let me try to finish this out. I see the time. I acknowledge the time. We're almost there. You can see the result there. And then the sum of an infinite geometric sequence. So if the absolute value of R is less than 1, then the sum of the infinite geometric sequence where it goes on forever is given by this guy. So I think in the previous derivation, we had that the sum of the first n terms of the geometric was A1 times 1 minus R to the power of n over 1 minus R, right? But if the absolute value of R is between 0 and 1, in other words, it's less than 1, and we let n go to infinity, if we let n go to infinity where the ratio is between 0 and 1, then this term goes to 0. It converges, right? So then once that term R to the n goes to 0, we finish with this guy here. So again, you don't need to know about the derivation. The whole point is the sum of an infinite geometric sequence is going to be. Okay. That's as long as the common ratio is the absolute value that is less than 1. Okay. All right. I don't. Okay, let's go ahead and do this. This is the last one. Thank you. So we just said that the sum of an infinite geometric sequence is going to be A1 over 1 minus R, right? I think in this case, let me see, if we, that divided by 2, so we're multiplying by 3/4 each time, right? So then notice that our common ratio is the absolute value of 3/4 is less than 1. So this is going to converge to this form. So then the sum of infinite series adds up to 2 divided by 1 minus, what do we say, 3/4? So then that's 1/4. So then that result is 8. Again, if anything is not clear, feel free to unmute yourself and see how to do. I think this is good. You see it here, and the final result is 8. Right? Okay. So I can't think of any major announcements other than what we spoke on at the beginning. If there are burning questions, now is the ideal time to ask them. Let me check Zoom really quickly. Yeah, I just started fading towards the end. I just got really sleepy. like out of nowhere. Okay. So if there aren't any burning questions, we're going to end the session here. From one beautiful mind to another, enjoy the rest of your day. Okay, guys, take care. See you on Friday. Peace. Oh, wait a minute. Is this Friday? Is this Friday a holiday? Or is that next Friday? I think that's next Friday.